my, I don't even know how to say this. My history with this is that things have changed across the landscape of the way things are kind of taught when it comes to problems like this. And I don't think that you guys have much of a process in place, like how you would even start it. That's kind of what I got yesterday from third period when they asked about it. So how many of you understand how ratio problems are designed to be set up? A little bit? All right, so we are comparing what with what? Because all ratios are a comparison. Go ahead. We are comparing Earth and Moon, but I think it says we want to compare the Moon to the Earth, right? So, but what about the Moon are we comparing to the Earth? So when I read it different than I guess you guys. So let's read the first part. The acceleration on the Earth is approximately 10 meters per second squared. But on the Earth's moon, it's approximately 1.6 meters per second squared. If a golfer is able to hit the ball the same way on both the surface of the Earth and the surface of the moon, how much further would the ball travel on the moon? Okay, so we're not comparing necessarily gravity directly. We are comparing how far a ball would go. So of our list of variables here related to this problem, which of these variables are we comparing between the Earth and the moon? Delta X. We are comparing delta X between the Earth and the moon. Would you guys agree with that? Okay. So delta X for the moon is to be compared with delta X for the Earth. Does everybody understand? So it's a ratio. And this is the comparison we're making. Now, there's a couple ways we could approach this. One way to approach it is to consider that delta X equals Vx times t. Are either of those two variables going to be different on the moon than on the Earth? I think one of them will. I don't think the other one will. Which one do you think will stay the same on the Earth and moon? The velocity. It says in the problem, they hit the ball the same way. So that suggests that V naught and the angle will be the same both on the Earth and the moon. We all follow that line of reasoning? Does that seem like a reasonable line of reasoning? So if I sub this in, I would get a comparison between the Earth and moon will be equal to Vx time on the moon with Vx time on the Earth. Does that make sense to all of you? Now they asked me in the second part to compare this anyways, so we might as well compare them now, right? Because it looks to me like the distance the ball goes on the moon when compared to the Earth will be the same as how long the ball is in the air on the moon compared to the Earth. Any question about this yet? Well, let's consider the kinds of things that we can do with a projectile problem that has to do with the time that it spends in the air. If we were trying to set up one of these problems, we can't use what's over here because that's what's in our ratio. So let's see if we can use some of the stuff that's over here because that's not yet been brought into our ratio. And I think I need to bring in this. I think the acceleration is going to show up somewhere, right? So I'm thinking the stuff on the left side makes the most sense about trying to figure out how the time plays a role here. It's going to be type 2 problem. Ball's going to be hit and then land on the ground. So I'm going to start with delta y equals 0. I know that this would be v naught sine theta. And I'm just going to use a g here to represent the acceleration of gravity. I know one of them is 10 and one of them is 1.6, but I'm just going to put like a generic one here, and then I can replace it with 10 or 1.6 later. Does that all make sense? Is there a relationship that I could use that would have those three things in it that would allow me to solve for time? I think there is, right? I think we have some. So let's go ahead and kind of decide, do we want up to be positive or up to be negative? All right, so I'm going to go positive. That means that's positive and that's negative. And I'm going to use the same one we've been using more or less this whole time. Delta y equals 1/2 negative g t squared plus vy initial times t. Or 0 equals negative g over 2 t squared plus v naught sine theta times t. Can we solve this for t? Well, let me ask that different. Can you solve this for t? I'm doing your homework problem, but could you solve this for t? If you could, then you're probably gonna be okay. I'd factor out a t first. Factor out one of the t's, set it equal to 0. And then my other t will just be g over 2t equals v naught sine theta. I just move that term to the other side. I'm going to multiply both sides by 2. That gets rid of the 2's over there. Is that all good? Then divide both sides by g. I have an expression for the time. I know somebody yesterday said to me, and it wasn't in this class, I'm just having trouble with all the letters. Yeah, that's part of this class, is a lot of times what we have are just letters. However, if I put an E here, this would be the time for the Earth. And if I wanted the time for the moon, the top part stays the same, I would just put G for the moon. Is that all good so far? Yeah? So does that all make sense? You just put those two things over each other and then simplify, simplify, simplify until you get what's left. And what's left is 10 over 1.6. Is that good for number 1? You don't look convinced, but no problem. You kick 2 balls at the same angle. One, you kick twice as fast as the other. What is the ratio of the range of the faster ball to the other? So do we get the dynamics of the question? You may not understand where to start, but you get the dynamics. For a ratio problem like this, like any ratio problem, you need to find out what's being compared. So what's being compared here? Range. So I'm comparing delta x for the faster ball with delta x for the slower ball. Do you have an expression that you can use that describes delta x for each ball that would somehow incorporate an angle and a speed? Do you have something? I would probably use delta x equals v naught squared sine 2 theta over g. And then I'd probably do something like delta x for the fast ball and delta x for the slow ball. So v fast ball squared sine 2 theta divided by g, and maybe v slow ball squared sine of 2 theta over g. And is there anything I know about the fast ball and the slow ball? Go ahead. The fast ball is twice as fast as the slow ball, so maybe 2 times the slow ball squared. Just putting in the stuff I know. Find a relationship that has the variables in it that you're comparing. Put in the comparison. It's not a whole lot here. I'm going to divide these two things. Anything that's on top and bottom that's the same just cancels out. It appears I'm left with 2 squared v slow squared divided by v slow squared. Looks like the v slow is going to cancel out too. And I'm left with just 2 squared, or 4. So it looks like the faster ball will go 4 times further than the slower ball. Yeah, multiple choice. That's a multiple choice question that could show up on your test. Sure. There are other ways to do these. You could make up a number for the angle and the number for the speed, and then just double it and see what the change is. If you like it that way, do that way. I won't do it that way because I know it's coming in our future, and I know that that won't always work. So this is the way that I will show you as we do stuff. All right. Anything else on the homework you would like me to talk about? Go ahead. Number 5. A golf ball is struck at an angle of 35 degrees and a speed of 35 meters per second on level ground. What is the maximum height attained by the ball? We'll start with that question. So it says it's on level ground. The golf ball is struck at an angle of 35 degrees and 35 meters per second. I'm thinking something like that, and we want the maximum height attained by the ball. Well, I know the maximum height is attained when Vy equals 0. So I'm going to start with that basic idea and build out a chart. So the vertical side, I'll have delta y. I don't know. We're actually looking for that. How high does the ball go? What is its max height? So I want delta y. Vy initial is going to be 35 sine 35. Vy is going to be 0. I'm looking for the maximum height. Acceleration is going to be 10 meters per second squared. And I need to know, well, I don't need to know the time. But I don't have to worry about time. I have 3 pieces of information here. And obviously this has nothing to do with what's happening sideways. I don't need any of the sideways stuff yet. So I can find out how high it goes just by using those 3 pieces of information. I will have to decide whether up is positive or negative. And just for a change, I'm going to make up negative. That'll make gravity positive and my initial velocity negative. So Vy squared minus Vy initial squared equals 2a delta y. So it looks like 0 minus 35 sine 35, which is negative, quantity squared equals 2 times 10 times delta y. Let's see. 35 times 35 sine equals squared divided by 20. Looks like delta y equals negative 20 meters. Negative means upward. So that looks like part A of the problem. The maximum height attained by the ball is about 20 meters. Any question about that? Alrighty, moving along. How far would the ball travel along the ground? Okay. I assume that's asking where is the ball when it's at the maximum height? I don't really know. Problem's a little ambiguous. So we can either find that or we can find where the ball lands. Which one do you think the problem is asking about? All right, well, if I want to find out, say, where it is at its maximum height, I would need to know when it makes it to the maximum height. Does that make sense? So let's just do that. And then we can put that over here and find out where it is along the ground. I will need a relationship that has these things in it. And I think I got one. So I'm going to use Vy equals AT plus Vy initial. And that's going to be 0 equals 10 t minus 35 sine 35. So 35 times sine 35 is 20 divided by 10 tells me that it makes it to this point in 2 seconds. So this equals 2 seconds, and this equals 35 cosine 35. So delta x will equal 35 cosine 35 times 2. And that tells me that it's 57.6 meters. Now, I'm pretty sure if I want the whole distance it went, I would just double this, because that looks like it's in the middle. It's symmetrical. But we'll keep going. There is a 14-meter high tree 85 meters away from where the ball was struck. Will the ball make it over the tree? I don't know. But we can find out. That's a different question than this, though. This stuff is just about where the ball is at maximum height. The maximum height is high enough to make it over the tree, but that's only 57 meters from where it was struck. The tree is like over here someplace. So this is a different question. So I'm going to restart the question because it asks different things. I can leave some of the stuff the same. There we go. So get rid of all the stuff I don't need. We know the ball makes it to the 85 meter mark because we know that the ball travels about 114 meters. We found the midpoint was 57 meters, right? Wasn't that 57? I just erased it. But so we know the ball makes it far enough. So I'm going to figure out when is the ball 85 meters away. Because if I figure out when the ball is 85 meters away, I can use that time to figure out how high the ball is when it's 85 meters away. So that's what I'm going to do. So that'll be 85 equals 35 cosine 35 all times t. Looks like that time takes a little more than 2 seconds, 2.96 seconds. So it gets there at 2.96 seconds. I want to find out how high the ball is at 2.96 seconds. It's a lot to put in my calculator, but as I'm having difficulty with you guys participating, I'm just going to do it. You get negative 59.4225 there. And positive 43.808 there. So delta y equals negative 15.6 meters. So that means upward. Do I clear the 14-meter high tree? Yep, I am high enough. By about almost 1.5 meters, I clear the tree. I successfully do whatever I do when I golf. So absolutely no reason this couldn't be on your test tomorrow. This is not that tough. You didn't even have to solve a quadratic, so I'm more than fine with this on your test. All right. Any other questions on your homework that you'd like me to talk about? Go ahead. 3? There's 3 parts to number 3. I believe, right? So, is there a particular part or just the whole thing? Okay. So the plane is flying, and it's got a package, but just before it's going to drop the package, it hits a microburst, and it's now flying at an angle that is 30 degrees relative to the horizon. And it's downwards. Whatever the package is, I think we can all probably assume that the package, which is attached to the plane, also has got a 30-degree angle. So it's going to do one of these, hit the ground there. We're trying to figure out what delta x is. The plane is 8,000 meters in the air and is flying at 80 meters per second. Downward angle of 30 degrees. All right, I mean, no shortcuts here. Looks like this is going to be the whole thing. So vertical, horizontal, delta x, Vx, which will be, 80 cosine 30 degrees, and t. Delta y is going to be 8,000 meters, because the package is going to land 8,000 meters below where it started. Vy initial is going to be 80 sine 30 degrees. Vy final, I don't know. The acceleration is going to be 10 meters per second squared and time. Since you asked, do you want up to be positive or up to be negative? What's that? Up to be negative. Alrighty. If up is negative, then the package falls downwards 8,000 meters. It is got an initial velocity that's downwards. Wait, you said upwards is negative, right? Okay, so that makes this positive there. Yeah, and that's positive. And gravity's positive. Okay, everything's positive. Yeah, because everything's downwards. Yeah, I'm sorry. There, everything's positive. So we need time. No way to sugarcoat this. This one's going to be kind of yucky. So 8,000 half of 10 t squared plus 80 sine 30 times t. There's nothing fun there. You just got to do it. You can plot it, or you can just do the quadratic formula. This is 8,000 equals 5 t squared plus 40 t. And then I'll move the 8,000 over, so 0 equals 5 t squared plus 40 t minus 8,000. I can divide them all by 5, so that will be t squared plus 8t minus, I don't know, 8,000 divided by 5. I could probably do it, but 1,600. Negative b plus or minus the square root of b squared minus 4ac divided by 2a. So negative 8 plus or minus the square root of, God, this is a lot. 4 times 1,600 plus 64. So 64. Divided by 2. Square rooty. So I get negative 8 plus or minus 80.4 divided by 2. I don't want the negative one. I want the positive one, so I'm going to ignore the negative there, and I'm just going to add. So, and I get a time of 36 seconds. And I don't think that this is too much work. I think you guys, did this in like the 4th grade or 5th grade. Maybe middle school, I don't know. Well, I don't know when you guys learn this anymore. We'll say middle school. But that's how you find the time. It didn't take long. I wrote down a lot of stuff so I could see it clearly. Get some scratch paper, you'll be fine. But now go back to my problem. 36 seconds and 36 seconds. So if I want to find out where it lands, Vx equals 80 cosine 30 all times 36. I mean, I'm still doing the same problem we've been doing for the last, couple of weeks. Solve for t and use it someplace else. So times 80 times 30 cosine equals, and I get delta x equals 2,508 meters. That's where I need to release the package, or it's how far along the ground the package travels until it hits the ground. How was that one? Was that one okay? By the way, you don't have to redo all of this. If the thing is fired upwards, it just changes one sign, this sign. And since it just changes that sign, it's just the other route. It just reverses the stuff here a little bit. So you just find the other one. Find the one where it's minus, and you'll get the other number you're going to get for the time that's in the air. It's just a little bit longer. But it doesn't change very much. It just changes that one negative sign. Yeah. No, that doesn't make any difference. You get the same number. I mean, if I had done the other one, I just would have had to do, negative 40 plus or minus the square root of 40 squared. It was just, I knew they all divided by 5. So since I was going to do it by hand, I figured I'll just divide by 5. I'm sorry, I can't hear you.
I don't get 2,500 feet. I get 2,000.
Did I multiply wrong? I mean, I left the time in my calculator, so I might have had it a little bit different. But alrighty, question number 4. A football player is going to kick a field goal that is 40 meters away from the uprights. The player intends to provide the ball with 22 meters per second at the kick at an angle of 45 degrees. How far away would the ball land if nothing got in the way? All right, let's start with that. I think that's a type 2 question in that the ball is going to land at the same height that it was kicked. The kick information is 45 degrees at 22 meters per second. So since it is a type 2 question, I could skip all that chart stuff and just do V0 squared sine of 2 theta divided by G. So for this one, that will be 22 squared sine of 2 times 45, all divided by 10. You do see that 45 degrees is like the sweet spot for how far you can make something go, because that's going to give you a sine of 90, and sine of 90 is 1, and that's the biggest value sine could ever have. So 45 degrees gives you maximum distance. That's only if there's no air resistance. If there's air resistance, the angle needs to be different than that. But either way, that's going to be 22 squared divided by 10, and that's 48.4 meters. All right, moving right along. Would the ball clear the goalpost, which is 3 meters off the ground at the 40-meter mark? All right, it is clear that the ball will make it to the 40-meter mark. Do we all agree with that? The ball goes 48 meters, so it will definitely make it to this place. That is the 40-meter mark. And it needs to be 3 meters off the ground. Well, let's see. I think this requires both the vertical and horizontal side to solve it. So I'm going to make a chart to kind of keep track of what I think is happening. My vertical side, I'll have delta y is unknown. I would like delta y to be greater than 3 meters. That way I make the goal. Vy initial will be 22 sine 45. Vy final is unknown. The acceleration is 10 meters per second squared, and time of flight. Delta x is known. We are asking specifically about something at the 40-meter mark. So I'm putting in the displacement of 40 meters. Vx is also known, 22 cosine 45. And again, I want the time. Now it looks like, again, you need 3 pieces on one side or 2 pieces on the other. Do I have enough information to solve for the time? Looks like I do. I'll have to use the horizontal side for that. So delta x equals Vx cosine theta times t, or 40 equals 22 cosine 45 times t. 40 divided by 22 divided by cosine. I get 2.57 seconds. I believe you should try and keep as many decimal places as you can in your calculator. I can only write down a little bit though, but it will make it there at 2.57 seconds. All right, I would like to know how high the ball is when it's been in the air for 2.57 seconds. So delta y equals, wait, I missed a step, and I should make sure I always do all the steps. I never went through and decided the direction of my vectors, and that's an issue here. So would you like up to be positive or up to be negative? If we choose up to be positive, that means this will be positive and this will be negative. Alrighty. So going on, delta y equals 1/2 times -10 times 2.57 squared plus 22 sine 45 times 2.57. Just gotta bust all that out. Now, you guys tend to make mistakes because a lot of the mistakes I see are just you guys rushing or not keeping yourself particularly well organized. So 2.57 squared times 5, that's negative 33.0245 plus, all right, 22 times 45 sine equals times 2.57 plus 39.9798. I get 6.96 meters. So the ball will be 6.96 meters above where it started. Is that enough to make it over the uprights? Yep, by a long shot. This one makes it, no problem. So, yay, this kick is good enough to score if it can pass the defenders. That's the next question. So, if defenders are located 3 meters from where the ball is placed and they are 2.5 meters tall, would the ball be blocked? Well, seems to me like we just repeat the problem again. There's not a bunch to change here. The difference is that I want to know how high the ball is, not at the 40 meter mark anymore, but at the 3 meter mark. So it's the exact same problem again, but now I'm doing this for the 3 meter mark. So we'll leave everything the same except for this. Oops, I could have left that there. Oh well. So 3 equals 22 cosine 45 all times t. I suspect this is a very short amount of time, but let's see. 3 divided by 22 divided by 45 cosine. I get a time of 0.193 seconds. I gotta redo this part again, so squared times 5, negative 0.186 plus 3.0023, 2.82 meters. Do I clear the defenders? Yes. By not very much, but enough. So, yay, score. And thus the Bucks lose again. So I have a plane and it is tipped upwards an angle of 30 degrees. Somebody in first period didn't understand this, but the package that's being dropped is a part of the plane before it's dropped. It doesn't just instantaneously have no velocity. It has whatever the velocity of the plane is. So if the plane is traveling at, I forget what it is, 80 meters per second. If the plane's traveling 80 meters per second, then the package is moving at 80 meters per second. And if the plane is making an angle of 30 degrees, then the package is making an angle of 30 degrees. So when the package is released, it will travel upwards first and then come downwards. So there's no shortcut on this problem. You just got to do all the math. This is 8,000 meters So I'll start my little chart here to get us going. And we did this problem in second period as well, but we did the other angle, the negative angle, so we'll see them both here. This is the vertical, this is the horizontal. Delta x, don't know, that's what we're looking for. Vx is gonna be 80 cosine 30 degrees in time, don't know. Delta y is gonna be 8,000 meters. Vy initial is going to be 80 sine 30 degrees. Vy final is unknown. The acceleration will be gravity, 10 meters per second squared, and then time. So you pick the problem, so you tell me whether upwards is positive or upwards is negative. All right, and to the right, do you want that to be positive or negative? All righty, so that makes downwards negative, upwards positive, downwards negative, to the right positive. All right? We need the time. So I have negative 8,000 equals 1/2 times negative 10 t squared plus 80 sine 30 all times t. It's not much to do here except we'll move the 8,000 to the other side and have negative 5 t squared plus 80 sine 30 is 40 t plus 8,000. You can divide this by 5 to make it easier, so I did, or negative 5, so I get t squared minus 8t minus 1,600. Now, there's no shortcut. You just got to find the time. And your choices are graph it or quadratic formula. Quadratic formula is not that tough. So negative b plus or minus the square root of b squared minus 4ac divided by 2a. All right, so that's 8 plus or minus the square root of 8 squared is 64. Minus minus is plus. 4 times 16 is 64, so 6,400 divided by 2. So that's 8 plus or minus the square root of 64 divided by 2. All right. 64 square root is 80. So 8 plus or minus 80.399 divided by 2. I'm not going to use the minus. I'm going to use the plus. So it'll be 8 plus 80. So I'll divide by 2. Tells me it's in the air for 44.2 seconds. Now, the only difference between this problem and if the angle is downwards is the sign that you make this. If the angle is downwards, then suddenly this sign changes, which means it changes the sign for B. It means this negative sign changes. That's it. That's the only difference between the first part of the problem and the second part of the problem. You don't have to do everything over again, just that. But for you guys who are trying desperately to see what's down there, I've written there for a while. You can do the quadratic formulas. You can. You're going to have to, tomorrow. Probably about 24 hours from now. Alrighty. That's got to be 44.2. That's got to be 44.2. So delta x equals, boy, these are boring, 80 cosine 30 times 44.2. I find delta x is 3,062 meters. Still, it's in the air for 0.0632 seconds and has to travel 50 meters in 0.0632 seconds so Vx is going to be this divided by 50, convert it, 791 meters per second. We didn't do one that's... So we only have 10 minutes, I think, before they're going to call you guys to go deal with your SAT readiness, so that you can be ready for the PSAT, which is kind of ridiculous because how many of you have already taken the PSAT? It's like 100% of you, because we all did it last year and the year before. Who's already taken an SAT? So it seems ridiculous to take the PSAT yet again. In fact, I'm not even sure what the point of that would be. But I could do all of this stuff, but this is a type 1 problem. So we know that Vy initial is 0. So it's going to fall 12 meters due to the action of gravity. This is exactly the same problem we did a minute ago. So this is how long it's in the air for. 12 divided by 5, square roots. I got 0.4899 seconds. Has to go 20 meters in that amount of time. Yeah. Oh, no, I'm sorry. I divided backwards. Sorry. I guess I'm just in a hurry. 12 divided by 5, take the square root, 1.5. So 1.55. So delta x is going to be 20. So 20 divided by 1.55 gives me a horizontal velocity of 12.9. We need that to do the actual problem. So the actual problem is to figure out where it lands if there's a ramp and the ramp is inclined 20 degrees. So suddenly the problem changes. We have a ramp. We'll be traveling 12.91 meters per second at an angle of 20 degrees. And we want to figure out where it lands now. So this is going to call us to do a little bit more work. We'll need to figure out how much longer it's in the air now. So delta y, still negative 12 meters. Vy initial will be 12.91 sine 20. Vy final, I don't know. Acceleration, 10 meters per second squared. Time. Delta x, don't know. Vx, 12.91 cosine 20 nt. Alrighty. Negative 12 equals 1/2 times negative 10 t squared plus 12.91 sine 20 times t. 0 equals negative 5 t squared plus 12.91 times 20 sine equals... That's not true. 12.91 times 20 sine equals 4.415. That's plus t plus 12. You could plot it or quadratic formula it. So negative b plus or minus the square root of b squared, 19.496, minus 4ac. All right. All divided by 2a. All right, so 4 times 5 times 12. I get the square root of 259.496 plus or minus negative 4.415, all divided by negative 10. Boy, this is a lot of work. I'd ask you guys, but whenever I ask you guys to do this kind of stuff, I tend to get so many different answers. And there's only going to be one. But that'll be your problem on the test too. Let's see. I think I'm going to use the negative sign, right? Because if I use the plus sign, I'll get a negative answer. So I'll use the negative sign. And so it's in the air for a whole 2.05 seconds. A lot of work to get 2.05 seconds. 2.05 seconds. So where does it land? Times 12.91 times 20 cosine. I get delta x equals a whole 24.9 meters. So it shifted the landing 5 meters further away. Formula sheet. This will be on the formula sheet. This will be on the formula sheet. This will be on the formula sheet. And that's it. I mean, there's lots of other formulas, but these are the only ones that are on the formula sheet. So this one, I don't believe is on the formula sheet. It hasn't been in the past. And this one usually isn't on the formula sheet either. Not that you guys use these very much for the projection, for the projectile motion problems. But also, if you want this, you have to bring it. And if you want this, you've got to bring it. And if you don't want to work out your trig, you'll have to bring those.
Yeah, thank you.
If you want to.
And also, can I come in on first period on Friday
Yeah.
to take it?
Can you what?
Can I come in on first period? on
Probably.
Friday?
Wait, Alan, hold on.
Should I send you a message or should I just like
It's just
show
whether I
up?
have it photocopied by then or not.
Okay. Okay, thank you.
The ceiling tile? Can I just? Yeah, I'm gonna do it over the.
Is it fine if I come in lunch Friday instead? Thank you.
And are you being fire Bye, Mr. Shelton. Have a good week. Or like on question 5, where it's like asking like the maximum height.
Then you're finding out the final y velocity is zero. And you're finding out that tells you how the maximum height. So if it was like you wouldn't be able to use, if we go back to, all right, so this is a pretty standard projectile motion problem, except that because there's going to be a launch velocity, I've got no zeros to introduce. So vertical, horizontal, and let's see, delta y, 8,000 meters, Vy initial, 80 sine 30, Vy final, don't know, acceleration, 10 meters per second squared, time. Delta x, don't know, Vx, 80 cosine 30 degrees, time, don't know. Since it's your problem, do you want upwards to be positive or upwards to be negative? What's that? Upwards is positive. Do you want the right to be positive or the right to be negative? Right to be positive. All righty. The package falls downwards 8,000 meters, has an initial downwards velocity of 80 sine 30 and has a downwards acceleration of 10. But it is traveling to the right. So there we go. I need to find the time because I don't have any. Go ahead.
I have a quick question about
Believe you.
the y initial and the dx. I know you have to use sine and cosine and line, but like, for how do I know if I'm reading a problem, how would I know I need to use sine and cosine and not?
What else is there to use?
Well, if it's already given to me. Well, oh, wait.
So I need to figure out the time. I think we'll get that from all this stuff that's right here. So negative 8,000 equals 1/2 times negative 10 t squared plus, oh no, not plus, minus 80 sine 30 times t. We need to solve that for t. There's no like shortcut here unless you want to plug it into your calculator. You just got to do the work. So negative 8,000 equals negative 5 t squared. Sine of 30 is 1/2 and 80 times 1/2 is 40. So minus 40 t. Let's see, 0 equals negative 5 t squared minus 40 t plus 8,000. Now we could just do the Pythagorean theorem now, but I'm going to divide by negative 5 since all of those are divisible by 5. That'll make not the Pythagorean theorem, the quadratic formula there. So divide by negative 5 and I'll get positive 8 and negative 1,600. That's not factorable. So, I mean, it looks like it could be, but it is not. So quadratic formula or plot it. Yeah. Yeah.
So why in some equations you factor out the t's that only is type 1?
Well, I would factor out the t if there was a t in this term, but there's not. Yeah, that's why I can't do it here. So let's do it. Negative 8 plus or minus the square root of negative 8 squared minus 4 times 1 times negative 1,600. Oh, wait. Why did I put a negative 8 in there? Negative b plus or minus b squared. There we go. Divided by 2a. I'm amazed at the number of you who find this stuff to be a challenge. Part of the reason is because you try to do it all on your calculator. Look, just don't bother. Just take your time and write it out. 8 squared is 64. 4 times 16 is 64. So this is plus 6,400. All divided by 2. That's negative 8 plus or minus the square root of 64 divided by 2. Pretty sure I'm just going to be using the plus down there, but let's go ahead and figure out what the square root of 64 is. 64 is. So square root 64. I get 80.4. So this is negative 8 plus or minus 80.4 divided by 2. Well, I don't want the negative one. I want the positive one. So that'll be 72.4 divided by 2, or 36.2 seconds. Now that I know that's 36.2, put it there and there. But also, before we move on, if the angle were this way, that only changes one thing. It changes this, which changes that. Makes that positive. So the whole problem is basically the same, just changes one sign. So you can use all the same work again. Either way, to find where it lands, delta x equals 80 cosine 30 times 36.2. Delta x is where along the line, where along the ground it will land. So it wants to know how far in advance. That's how far in advance. Because it's, remember, you need to be that far away because it's going to hit there. Does that make sense? Ones where there's two launch angles. Sure. So I would like to launch something that's going to land 50 meters away. I launch at 30 meters per second. What angle would work? Got it? All right, so I'm looking for an angle that works. The only way for you guys to solve this kind of problem with the skill set you have is to use the range equation. It's the only way. So it's a problem that's going to give you the launch velocity and the displacement, and you're asked to find the angle. So if I put in the information that's been given, you've got to be kidding. What, every single one of the APs needs to get out there at least once and talk to sound like they're... Great faculty meeting. I already went to that waste of time. And yes, I'm recording this. And yes, I don't care if it gets posted. It was a waste of time. Been here 20 years, telling the same stuff over and over again. All right, so 500 equals 900 sine 2 theta. Still got to solve for theta, so 500 divided by 900 equals sine 2 theta. I'm doing a lot of extra steps here because I've seen some of you do algebra, and some of you are really in trouble. 500 divided by 900 is 5/9, but it's also 0.55555 repeating. So stop at this moment and make sure that the number over there is less than 1. Because I could see me on a test giving a problem like this where that is not less than 1 and you flipping out, but you would have to know if that number is greater than 1, then you can't reach the target. The velocity isn't great enough. Everybody understand? I'm telling you an answer to a question if you pay close attention. So if that number is greater than 1, then the velocity is too small to reach the target. All right, but that being said, I need to do the inverse sine of 0.5555556. I get sine of 2 theta equals 33.7 degrees. This is not the answer. But boy, I bet if I was doing this as a multiple choice, I would list this as one of the answers. But the actual, it's not sine 2 theta equals that. Just 2 theta equals that. Sorry, use your erasers. You are the ones who are writing blindly. You should have been paying attention. But the actual answer is to take that number and divide by 2. But that is not the only answer that will work. There's another answer that will work. The complement of this number. So if I subtract that from 90, I will find that 73 degrees is also a clear and okay answer. Both angles will get you to the target. One is the high angle, one is the low angle.
So it doesn't matter which one you find.
Oh, I think it matters.
He's going to be asked
I'm going to ask in such a way that you might have to choose from one of those two.
to go over an object.
Yeah. Like there's an object in the middle. Which angle is most likely to get you over it? Which one will spend more time in the air? Which one will spend less time in the air? Or something like that. What?
We're doing, if, like, we're doing, we come in Friday instead and take the test early, so we don't have to do the test Monday. Like on,
Wait, you just said you come in early on Friday
like
and
lunch.
come in Friday instead.
Yeah.
Lunch
yeah, like,
instead.
Yeah.
You didn't say that. You said, can you come in on
what I
Friday
meant.
instead?
I don't know how to
Bye. Be safe. Help your parents.
Can I see the equations that you were showing? Or I can just like take